Introducing gpt-oss-safeguard. The central question here is whether safety policies can be updated without the need for model retraining.
Okay, so to understand the proposed solution, we first have to establish the standard approach to content safety and its challenges. What does that traditional workflow look like? The standard method uses a safety classifier. This model is trained on thousands of manually labeled examples of content. A key detail is that the classifier never sees the policy text itself. It only infers the policy from the provided labels. This process has several steps. First, curate thousands of examples. Second, manually label them. Third, train the classifier. And fourth, if the policy changes, you have to retrain the entire model.
So that's the bottleneck. Because the policy is inferred, not directly interpreted, any change requires starting the process over. This makes the system inflexible. Correct. So, this paper introduces a reasoning-based approach. The model is designed to interpret the policy directly at inference time. The paper releases two open-weight models, a 120 billion and a 20 billion parameter version, under an Apache 2.0 license. At inference, they interpret a user-provided policy and output not just a classification, but also a chain of thought explaining the reasoning behind it. And this shifts control. The developer provides the policy directly, which allows classifications to be tailored to specific contexts, like a gaming community versus a financial forum. The paper outlines 4 situations where this approach is particularly suitable: for emerging or evolving harms, for highly nuanced content, when there aren't enough labeled samples to train a dedicated classifier, and in cases where explainability is a higher priority than latency. So that brings us to performance. How are these models evaluated? The main internal evaluation was a multi-policy accuracy test. In this task, the model must correctly classify a piece of content under several different policies simultaneously. To be counted as correct, the classification had to match all golden labels for all policies for that specific input. And the results on that specific task is that these smaller GPT-oss-safeguard models reported higher accuracy than the GPT-5 thinking model. They also tested on 2 public benchmarks. On the 2022 moderation dataset, the models slightly outperformed the other models tested. On the toxic chat benchmark, the internal safety reasoner and GPT-5 thinking performed marginally better. Okay, let's talk about the practical side. What are the stated trade-offs and limitations of this reasoning-based method? The paper states 2 primary limitations. First, that a dedicated classifier trained on tens of thousands of high-quality labeled examples can still achieve higher performance. Second, the reasoning process is slow and compute-intensive, which makes it difficult to scale. And they provide a number for that compute cost. In some of their recent product launches, up to 16% of the total compute was used for safety reasoning. To address this, they describe their internal mitigation strategy. They use smaller, faster classifiers as an initial screen for some content, and they run the more intensive reasoning process asynchronously to prevent user-facing latency. So, what are the direct takeaways for developers or researchers looking at this work? The paper concludes with 5 takeaways. 1. Apply custom safety policies directly at inference. 2. Review the model's chain of thought to understand decisions. 3. Update policies iteratively without model retraining. 4. Use this method for nuanced or rapidly evolving content risks. And 5. Consider a hybrid approach with faster classifiers to manage compute costs.